Hello everyone, this is CH Rupasri of Bpharmacy 3rd year studying in Maharaja's College of Pharmacy, Poolbag, Vizianagaram. Today I am here to introduce the topic of artificial RBC using nanotechnology. As we all know that the nanotechnology is defined as a fabrication of devices with the precision to the scale of 1 to 100 nanometers. The scale yields precision on the atomic or molecular scale. Nanotechnology is also referred to as molecular manufacturing. Nanotechnology has the potential for a nearly limitless number of applications in the wide range of fields such as physics, biology, engineering, chemistry and computer science. Artificial RBC is also known as respirocyte. Coming to the artificial RBC, what is artificial blood? Artificial blood is a substance used to mimic and fulfill some functions of biological blood, usually in the oxygen carrying sense. Its main aim is to provide an alternate to the blood or blood-based products from one person to another. Hemoglobin molecules extracted from the RBC are modified by microencapsulation or cross-linkage to produce the red blood cell substitutes. A lot of research is being done on focusing on the hemoglobin-based products, which include PEG modified liposome encapsulated hemoglobin, nanoparticle and polymerosome encapsulated hemoglobin, and polymerized hemoglobin solutions. One example of oxygen carrier encapsulates a solution of concentrated hemoglobin is called hemoglobin vesicle. Hemoglobin vesicle was found to have oxygen carrying capacity comparable to that of the normal RBC. The encapsulation and linkage process stabilize the hemoglobin molecules and also allow permeant molecules such as oxygen and substrates to enter and allow metabolic products, peptides and other materials to leave. In this way, the enclosed materials are protected from the immunological rejection and from other materials in the external environment. There are many situations wherein modified hemoglobin has the potential to substitute for red blood cells, including the surgery and emergency treatment for severe traumatic injuries resulting from the traffic accidents and other accidents that cause severe bleeding and hemorrhagic shock. Modified hemoglobin does not contain the red blood cell membrane and therefore no blood group antigen. It can be used without the need for cross-matching or typing. Any person with any blood group can use this artificial RBC. Modified hemoglobin can be lyophilized and stored as a stable dried powder that can be reconstituted with the appropriate salt solution just before use. That is, it is available in the form of a powder which whenever necessary it is reconstituted with the appropriate saline and they can be used. And coming to the advantages of the artificial RBC, it is having the high oxygen carrying capacity and it do not have any blood group antigens and it is having the longer half-life and majorly it is non-toxic. Coming to the extraction of HB from the RBCs, RBCs contain HB which transport oxygen throughout the body. RBCs are lysed with E-pure water to extract the hemoglobin. Hemoglobin must be cross-linked when placed in the bloodstream. Hemoglobin breaks into dimers which can travel through the capillary poles and cause the death. So the cross-linked HB can no longer travel through these pores, so it is very beneficial. And next, coming to the differences between the RBC and artificial blood cells. In the RBC, they are having the blood group antigens and in the artificial RBC, there are no blood group antigens and in the RBC, infective agents can be removed and infective agents cannot be removed or sterilized. In coming to the artificial RBC, all the infective agents can be removed and sterilized. Standard storage at 4 degrees only stable for 42 days in case of the red blood cells. In case of the artificial RBC, they are stable membrane and they are having a longer storage, and in RBC they are having the limited availability, and in case of the artificial RBC they are having the unlimited availability and hemoglobin is from the different sources. Coming to the size of the artificial RBC, several investigations have been conducted in order to find the ideal size requirements for nanoparticles developed as oxygen carrying artificial cells. Theoretically, the nanoparticles must be able to circulate freely through even the smallest of the capillaries, which can be as small as 4 to 7 μm in diameter. However, the nanoparticles with diameters below approximately 70 nanometers will be removed by the liver. As a result, it has been suggested that 70 to 200 nanometers is optimal for the intravenous delivery and circulation. Coming to the pegylation, artificial cells modified with PEZ have longer circulation times. Incorporation of polyethylene glycol (PEG) to the lipid membrane result in marketed improvement in the circulation time of hemoglobin. Coming to the properties of the nanodimension RBCs, they will contain little or no lipid in the membrane, persist in the circulation after infusion for a sufficiently long time, they are stable in storage and remain stable after infusion from the duration of its function as a blood substitute, but it has to be degraded soon after the completion of its activity from the body. The membrane material and the degradation products have been non-toxic. In addition to the hemoglobin, the nano artificial cells should contain the important RBC enzymes like superoxide dismutase, catalase, carbonic anhydrase and methemoglobin reductase. The membrane should be permeable to reducing agents and glucose. Next, coming to the applications, these are used in the aid in the cancer therapy, hemoperfusion, used as temporary replacement for natural blood cells in case of emergency, and it is used in the treatment of chronic anemia. And coming to the conclusion, the ability to build products by molecular manufacturing would create a radical improvement in the manufacture of technologically advanced products. Artificial RBCs could also be used as a complete or partial symptomatic treatment for virtually all forms of anemia. They can deliver oxygen to the muscle tissue faster than the lungs. They can also be used for other problems with gases in the bloodstream. Thank you.